right. But today we're going to look at exam 1 in review. So before I get started, anybody have any specific problems, especially if you worked through those practice problems in the review document and found some that you just couldn't solve? No? Oh, maybe we ought to just take a break, come back for lab. Okay. All right. Which one are we starting with? Let me share the document. Get it up on the board. And here it is. There we go. Okay, what number? Let's see, are they?
Give me 1 second. I gotta find what I don't think.
Okay, they're numbered in sequence front to back, so we don't have to worry about chapters. Did you find it yet?
I struggled with chapter 3. Chapter 3 today.
Okay. Is that most everybody's consensus? Chapter 3 give everybody trouble? Let's see, where did chapter 3 problems start? That's the thing. Oh, here they are. Chapter 3. All right, let's see. 115, beginning in 115. Here we go. Okay, that's on the board. Can you see that in the back of the room? I tried to make it as big as I could. Yep. Okay. All right, any particular ones?
All of them from 150 down.
150? 150, okay. Oh, it's probably not so much the problem of the material as it is the way the problem is presented. These types of problems are a real bear to deal with.
I didn't even understand it, so I couldn't even try.
Yeah. Okay. So maybe after we do a couple of them, the way that it's presented will become clear. We'll just start with the first one. Let me get my picture out of the way. Here we go. All right. So each one of this type of problem has there we go, has statements, answers that are in the same format for every one. All 3 are true, 2 of the 3 are true, only 1 statement is true, and none are true. That type of arrangement. And you have to look at each one of the statements in the problem text and decide how many of them are true. So in this one, number 1 right here, right there, the number of elements that are metals and non-metals is approximately equal. Is that true or false?
False.
Right. What are most of the elements in the periodic table? Metals or non-metals?
Oh, no. No.
You had a 50-50 chance. So they're metals. Remember that black line you had to draw on the graph?
Oh.
In this one, it's a red line. These are non-metals. These are all metals here, here, and here. So most of the table is metals. So that one's false. So let me keep track. This is 150. All right, that one is false. How about 2? The number of orbitals present in an electron subshell is always 6. Yeah, it varies, doesn't it?
Yeah.
Right. The number, and it depends on what their principal quantum number is. N equals 1. There's only one orbital. That's all it can be. 2. What if your principal number is 2? How many can you have? If N equals 2, then L equals 0, 1. Oh, excuse me, 0 or 1. Okay, so it can only have 2. So that's right. It varies depending on the principal quantum number, how many orbitals you can have. So that one's false. Okay, last one. An atom as a whole is electrically neutral because all charged subatomic particles reside in the nucleus. Yeah, well, part of that statement is true, is it not? An atom as a whole is electrically neutral, but not because of all the particles in the nucleus. What's in the nucleus? All the positive charges, all the protons. And then what else? Right? Think isotopes. Neutrons. The nucleus has protons and neutrons in it. And then, so if that's true, where are the negative charges? Yeah, they're out here, right? The little dense nucleus is here, and all the electrons are out here. So that's what makes the statement false. It's the explanation for why the atom is neutral, not that the atom is neutral. Okay, so all of them are false. That's why the answer is D. None of those statements are true. Okay, that's going to be the pattern for this type of question. I don't want to eat up all our time on these types of questions. Is there one of them that really rang your bell? She didn't hear me, did she? Oh, okay. I just wondered if your hearing's better than mine. It doesn't take.
Can you do like a couple on like 160, like 160,
160? Oh, yeah, okay. So, (160). Choose the correct atom that has an atomic number of 17. So what's the symbol for atomic number? Right? Z equals 17. Okay. So does that give us enough information to identify the element? Yeah. Right. Each element has a unique atomic number, which is also the number of protons. So you just look at your table, follow on until you find 17 in the atomic number place, and they're always whole numbers. Can you see the chart from there? Which one is it? Chlorine. Yeah. And there are no other chlorines in those selections. Let's check just to be sure. It says chlorine that, and it also gives the mass number of 37. So how many neutrons would it have? 20, right? Is that reasonable for chlorine? The way you tell whether it's reasonable is look at the atomic weight or the molar mass in the periodic table. It says 35.45. (35.45). Okay, so that's reasonable. It's a little high. So this particular isotope is probably not very common. It's a very small percentage of the naturally occurring abundance. Most of them are probably in the neighborhood of 35. And then you have another one that's probably 36, bumps it up a little, and then 37 bumps it up a little more. Okay. That's the logic behind using this information to answer questions. Okay. 161. Okay, 161. Now we're looking at the mass number, and its symbol is what? A equals 17. So for this one, you need to look at the number on the upper left-hand corner of each element. Right? It won't be chlorine this time because we're not talking about protons. We're not talking about atomic number. We're talking about mass number, which is protons plus neutrons. So you're looking in the upper left-hand corner. And that leaves this one out. None of these even come close. That one looks like it's probably, I can't highlight it. There it is. There you go. Fluorine, 17 in that position. Okay. Let's see. Choose the correct atom that has a nuclear charge of plus 17. Okay. This is another way of saying the same thing in 160. If the nucleus has a charge of plus 17, that means it has 17 protons, right? Because there's nothing in the nucleus other than the positives to balance it. So nuclear charge would be plus 17. And if it were neutral, it would have minus 17 or 17 electrons out in the cloud. So the same answer here as 160 is chlorine. Is that clear as mud? Okay, choose the correct atom, 163. Choose the correct atom that has an equal number of protons, neutrons, and electrons. So the number of protons equals the number of neutrons equals the number of electrons. That's the condition, right? We read the problem, and what's the question? We got to have a clear understanding of what the question is, otherwise never find the answer. So what are we looking for? Well, we're looking for an element here that has no charge. If the electrons are equal to the protons, it has to be neutral, right? Over here, we're looking for the Z number, and then the A has to be equal to 2 times Z, right? You have to have the same number of this as that, so 2 times Z would meet that condition, correct? Okay. So which one satisfies? Let's see, the first one is magnesium 1225. Right? 25 is not double 12, right? But it is neutral. We still don't have the right one. How about this one? Calcium 2040. It's neutral. Z and A is 2 times Z. Okay, we found our answer. In a multiple choice test question, if you don't have those squirrely ones like none of the above or 2 of the above or that type of thing, you can just go down from A to D or A to E, whichever the case may be. And when you find the right answer, you can stop and move on. So the answer here is B, calcium 40 meets those conditions. Right? If you're OCD, then you'll have to go down and do them all. All right. 164. That one looks puzzling at the beginning. Choose the correct atom that has fewer neutrons than electrons. Okay. So if we have this, and we have that number, and they're all neutral. So the number of electrons is equal to the Z number. All right? So the number of neutrons has to be less than Z. And how do you find the number of neutrons? You subtract Z from A. So if we say Z minus A equals the number of neutrons, then that has to be less than Z. Right, so what are our choices? Magnesium. So 12 from that is 13, right? So the number of neutrons is greater than the Z number. That can't be it. How about calcium? All right, so the number of neutrons is 20. That's exactly equal to, right? So that can't be it. How about fluorine? 9 from 17 is what? 8 neutrons. That's less than Z. It's also less than the number of electrons. So that's our answer right there. Okay.
So how did you get the number of electrons? How did you show the number of electrons?
The number of electrons was equal to Z because the atom is neutral. So we just had to find out how many neutrons and compare it to Z. Yeah. Okay. Choose the, okay, 165. Choose the appropriate pair of atoms that contain the same number of protons. Right? They have to have the same Z numbers, same number of protons. What does that mean? They've got to be the same element. You got to have the same symbol, right? And which one matches that? Only the last one, right? Lithium, lithium. That satisfies the conditions of the question. Okay? All right, 166 is sort of the same. It's like a fraternal twin for 165. 160. Yeah, 165. Choose the pair of atoms that contain the same number of electrons. Well, all of your examples are neutral. So the Z numbers have to be equal also, if the number of electrons are equal. Right? This is just testing if you know that in a neutral atom, the number of electrons is equal to the number of protons. It's just another way of asking the same question. So that's lithium also for this one. In order to have the same number of electrons, it has to have the same number of protons. Now, 167 is a little bit different. You want the same number of neutrons. So you're going to have to subtract the Z from the A and find out what that value is. So for the first one, 6 from 13 on carbon. Right? How many neutrons is that? 7. How about the other one? 6. Okay, that can't be it. That's A. How about chlorine? 17 from 37 is what? 20 neutrons. And 18 from 36 is 18. That can't be it. How about C? Oxygen and fluorine. 8 from 18 for oxygen is 10 neutrons. And 9 from 19 is 10 neutrons. There you go. The answer is C. All right, let's do 168 because it uses a word that we haven't used in class yet. Maybe your textbook has it, but I never used it in class. Choose the pair of atoms that contain the same number of nucleons. So what's a nucleon? It's any particle that resides in the nucleus. So it could be a proton, it could be a neutron. Right? So the nucleons would be equal to A. Not the answer A, I mean big A, the mass number. So find those that have the same mass number, and the only one that matches is A, little a. Carbon and nitrogen, carbon 13, nitrogen 13. They have the same number of nucleons, protons plus neutrons. All right, how about 169? Choose the pair that has the same number of subatomic particles. Well, they're all neutral, which means the number of protons equals the number of electrons. All right, so you don't have to do any calculations with charges. So this is kind of like 168, same number of nucleons. See, subatomic particles, okay. All right, we better take this one in order. So our first choice is carbon 13 and nitrogen 13. Okay, subatomic particles. So we have A should be a valid answer for that one, shouldn't it? I think that's the wrong answer. B's the wrong answer. Subatomic particles would be the number of protons, number of neutrons, and the number of electrons. Yeah, it doesn't say where they are, so it's in the whole atom. Right, so we've got protons and neutrons are here and here. Oh, no. A is not the right answer. Why? Because this here is 13. But for carbon, this one's 6. And for nitrogen, it's 7. Right? So it can't have the same number. Anybody see where I was running down the wrong rabbit hole? Okay. Let's look at chlorine and argon. Okay, 17 and 18. And the mass numbers, 37 and 36. Okay. So the protons and neutrons, this one's 37, this one's 36. This one has 17 electrons, and this one has 18 electrons. 54 and 54. There you go. That's your answer. All right. So the next problem looks like it's a electronic configuration. Choose the appropriate electron configuration for an element that has 5 completely filled subshells. 5 completely filled subshells. So we have to remember that, let's see, 170. How many can you maximum have in the S shell? 2. How about P? 6. And that's all we have in our answers, S's and P's, nothing else. So you just look down and see, okay, first of all, which ones are full? The only one that's full is A. A is completely full. Let's see, 1, 2, 3. Okay, is that right? Yep. So then you want to ask yourself, just to be sure, is this a correct configuration, electronic configuration? Yep, they're in the right order. 1S fills first, 2S fills next, 2P fills next. Then you go down to the third period, 3S fills and 3P fills. Okay. So by the way, what element is this? 6, 8, 16, 17, 18. Looks like argon. Okay.
That one's true. We did one more.
Yeah. Let's see, 171. Okay, choose the appropriate electron configuration for an element whose third shell contains 6 electrons. Okay, so the third one would be 3S and 3P. Right? That's all you can get out of the third shell. That number's not big enough to give you D's. You can only have S's and P's. So if it's full, it has 2 and 6 here, right? But if we start backing down, right, 5, 4, 3, 2, 1, or even that's gone, and you only have, you could have 2 here, but the third one would be incomplete. So which one matches that? Third shell contains 6 electrons. Remember, they fill from the lower energy to the higher energy. So we have to put 2 here before we can go to the next one. Right, so that's 6. Which one has 3s2 and 3p4? B. B answers that one. Okay. Another one? It takes a lot of practice. Yeah. If you're short on time, then I don't know what to tell you. Choose 172. Choose the appropriate electron configuration for an element that has electrons in 6 orbitals. 6 orbitals. All right. I think what we're getting at here, we need to show the suborbitals. Right. We have 1s, 2s, and these only have 1 level in them. 2p has 3 levels. Okay. Then 3s has 1 level, and 3p has 3 levels. Electrons in 6 orbitals. So if we're filling from left to right, we'd have to have this one, 1, 2, 3, 4, 5, 6. We'd stop here. So which one stops at 3s? 1, 2, 1, 2, 3, 4, 5. You know, that one might be wrong also. Oh, I'm looking I'm looking at the wrong one. 172. 172. So yeah, that's right. So you would have a 2 here, a 2 here, 6 here, and something here. Right. This would be like that, like that. And whatever's over here, you could have 1 or you could have 2. So the one that satisfies that condition is C. This is testing whether you remember that P's have 3 sublevels. X, Y, and Z. We usually call them that. Why? Because the P denotes orientation in space. X orientation, Y orientation, or Z orientation. You good on that one?
I'm taking notes.
Okay. Let's look at one more. This is a good one too, 173. We want to find 2 unpaired electrons. Two unpaired electrons. Okay. That could come from either S's or P's. Okay, remember, these have 1, these have 3, that one's 1, and this one's 3. So if we fill from left to right, let's see, here's the way I would approach this. As we fill in electrons, what's the first electronic configuration where you have 2 unpaired? Right? That's hydrogen. That's helium. Right? Those are paired now. It's only 1. Right? There's an unpaired. But we go up to beryllium and it's paired again. So let's do this one. 1, 2. Okay. That one could be an example. 2p2. Let's look for that one. No. There's nothing in there that satisfies that. So we just keep going. Right? That's 3 unpaired. We can go like that. 2p4. Oh, nothing. I'm looking at the answers, and there's nothing in there with 2p4. So we're going to go fill them up and then move to this one. Okay, there's 1, 2. How about that one and that one? Now you have 2 unpaired. 3p2. Is there a 3p2 in there? Nope. So let's go there and there. Now we've got 2 unpaired. Is there a 3p4? Yep. B. B has a 3p4. 2 unpaired electrons. Okay. Did everybody see how I solved that problem? It was, you could almost call it brute force. Let's see. 174 goes through, I would go through that same procedure and find no unpaired electrons. And then as I get to unpaired, then I look and see, is anything matching that one? If not, I just keep going until I get unpaired again. Actually, if you don't have any S's at the very end of the configuration that have 2 electrons in them, then you go to the P's and see if they're filled. And the only one that's got filled orbitals is A. All right. How we doing? Coming up on 10. Okay. How about 175? Was that? Yeah, you said to the end, right? Yeah, sure. Right, we're skipping everything in chapter 1 and 2, right? Everybody's good on 1 and 2.
Chapter 3 is still.
Yeah, I understand. That makes perfect sense. Pair of elements that are in the same period of the periodic table. So if they're in the same period, they ought to be, first of all, they ought to be very close to the same atomic number. It won't be exact because they're different elements. So if you see that two that are wildly apart, like B, nitrogen and lead, they can't be in the same period, right? They're too far apart with the numbers of protons. Fluorine and chlorine, they can't be in the same period because they're in the same family. And you can't have two members of the same family in the same period, right? Process of elimination. How about molybdenum and rhenium? Well, they're probably not close together because what's the maximum number of electrons you can go from S, D, and P? S is 2, P is 6. 1, 2, 3, 4, 5, 6. Okay, that's 8. And D's are 10, right? So that's 18. You can have 18 across on a period. If these numbers are farther apart than 18, then they're probably not in the same period. And rhenium and molybdenum are how far apart? 23? Now, the only exception to that is if you run into the F's. Right? If you get down into, here, right here, here. So this could be a problem because rhenium is after you get through the lanthanides. So in that case, what you need to do is go to your periodic table and say, and find them. There's rhenium. And molybdenum is here. So they're definitely not the same period. Okay. All right, choose an appropriate pair, 177. An appropriate pair of elements that have the similar chemical properties. What do they need to be to have similar properties? They need to be in the same family, right? I say family, that's the old way. Now they call them groups. Okay, so which ones of these are in the same family? Well, let's see. Rubidium is an alkali metal. See on the far left, just below potassium. And strontium is an alkaline earth, right? So they won't have similar properties. Nitrogen and lead. Okay, nitrogen, in the nitrogen family, you have phosphorus, arsenic, antimony, bismuth. No, it's not there. Lead's not there. How about fluorine and chlorine?
So 177 and 176 going next to this question. Because we're probably asking for the temperature.
Oh, yeah. 176 and 177 are asking the same question with different wording. Yeah, exactly right. That's why the answer is exactly the same. Fluorine and chlorine are both halogens. So they will have similar properties. They're not going to be exact because they are different elements, but they will be very similar. All right. Okay, 178 is testing whether you know where the D area of the periodic table is. right? There's a name for that area. It's called transition elements. So that group, you got these two humps on either side and a space in the middle. Just follow that space all the way down. All those elements in there, well, I was going to say 40 of them. And that's true because the lanthanides and the actinides are filling F orbitals, so they wouldn't be part. So you just need to find the two elements that come from that central region, right? Rubidium, strontium, alkali metal, alkaline earth. Right? Nitrogen, lead. Nope, neither one of those. Fluorine, chlorine. Nope, those are halogens. Molybdenum and rhenium. Yep, they both come from that central region, transition elements. All of those elements that are shown there in that region are filling d orbitals. Right? So when you get to this level, fourth period, which d orbitals will be filled? 3 Ds, right? You come down one. 4s, 3d. 3d1 through 10. Okay. Fifth, these Ds are 4 Ds. The fifth period. When you get to the other side, you jump back up to 5 Ds. Okay. I'm not going to ask you any of these, but just out of curiosity. If you come along here, 6s lanthanum is 5D. But then you go down here, and these are 4 Fs. All these are 4 Fs, all 18. And then when you get finished with these, you come back up here, hafnium. Now you're back up to 5 Ds. Okay. That way you can use the periodic table to help you write your electronic configurations if you know how it's constructed. Now there's some flukes in that transition element area that we didn't talk about.
Yeah,
and
I don't know some of these definitions.
Yeah. What? Transition elements?
Well, like inner transition.
Oh, these are inner transitions. Because they fit right in here. We yanked them out. So the table wouldn't be twice as long as it is. But the inner transitions also, they're filling different orbitals. They're filling F orbitals.
The F.
F. F is in fail. Lost my train of thought. Okay. 179. Choose an appropriate pair of elements that have electronic configurations ending in P5. So it could be any number out here that allows for p orbitals, right? It would be 3 p's. It could be 3, it could be 4, it could be 5. Okay, so you just look and see, actually, where would we be filling P5s? Right, these are S's, these are P's. P1, P2, P3, P4, P5. Right, so you're looking for 2 halogens, aren't you? So let's see. The only 2 halogens up there are fluorine and chlorine. But wait a minute. Ending in P5. Yes. Yeah. Fluorine would be 2p5. Chlorine would be 3p5. Okay. This will be fluorine. This will be chlorine. Okay. Which of the following elements is a transition element? You just look at the table and match them up. Fluorine's not it, right? That's a halogen. How about tin? Where's tin? What's the symbol for tin? Oh, you should be able to rattle that one off. The Latin stannum is tin, right? It's not a transition element. How about AU? What's AU? Aha, somebody would remember that one. That's a transition element. Where's uranium? U. It's an inner transition element. It's in the actinide series. Well, that table says lanthanoid and actinoid. I don't know who built that table. I would call them ides. Okay. Which of the following elements is an inner transition? Well, we already said that. D, uranium is an inner transition element. Which is a halogen? See that one right off the bat. That's fluorine. A. Which of the following is both a metal and a representative element? So what are the representatives? Representatives come from the S area or the P area. Either one. So which of the following elements is both a metal and a representative? Okay. Fluorine is representative, but it's not a metal. Tin. Tin is representative, and it's also a metal because it's to the left of that zigzag line. So tin satisfies. Okay? Which of the following is both a non-metal and a representative? Well, we covered that one already. Fluorine is a non-metal and a representative. Right? It's got the same ones as before. Yes. It's in the S region, S orbital filling region here. Or the P orbital filling region.
Okay, so just in the non-transition.
Right. Just forget about these, and the rest of them are representative. Well, forget about these two. So forget about those and these. And the rest are representative. I don't know where they got that name. Doesn't make any sense to me. Representative of what? I don't know. Oops, that was the last one. Okay, we're down into the periodic table. We've also got, well, that's it, periodic table. Okay. What? Okay. You just need to know how to use it and find information like we've been doing.
So you're going to give it to us?
Yeah, that periodic table should be there. Let me check to be sure. Yeah. Yeah, there's a periodic table in the test. That's really your best friend.
Yeah.
Periodic table. All right. So we got another hour. Do we need to go back into chapter 1 and 2? Is there anything in 1 and 2 that's giving you problems? Okay. Let's go back to the top.
are we gonna have to know the formulas for like density and stuff?
Yeah. Yeah. Remember density? Mass per unit volume. Okay, that's it.
And then we have to know what Kelvin.
Okay. Kelvin equals degrees C plus 273. 3 significant figures is good enough. How about Fahrenheit and centigrade or Celsius? Here you go. Can you see that from the back of the room?
Yeah, I'm just writing down the expression.
Okay. Your book probably uses 1.8 there instead, but do your math and you find out that they're equal. I like 9/5 better. I use it to estimate. Did I mention this when you're driving by a bank and they have the temperature on their billboard, and it constantly changes. So if you're driving by, you can't stop and wait till it gives you Fahrenheit. So if it says Celsius, then I know that 20 degrees Celsius is equal to 68 degrees Fahrenheit. And if Celsius increases by 5 degrees, Fahrenheit increases by 9 degrees, 9/5. Okay. So if I drive by and their Celsius says 25, then I know that the temperature is 77. Okay. That's why I like it better. I already asked you what the body temperature in Celsius was, right? Anybody remember? Well, everybody knows Fahrenheit, right? 98.6. I've never seen anybody reach 98.6 unless they had a fever. I don't know where they got that number from. But if you do the calculation, right, put it in here and solve for that one, you get exactly 37 degrees Celsius. That's body temperature. Found anything yet? Or are you still copying? Okay. All right. While you're looking, if you find any others, we'll cover them. Next week, we'll have exam on, well, you already know that. Exam 1 on chapters 1, 2, and 3. And then we'll go right into chapter 4 and talk about chemical bonding. And these chapters on chemical bonding, we're also going to learn how to name compounds. Okay, so that's why the next extra credit is that 50 ways to name a compound. It's got it has a formula, and the answer is the name. Sometimes it has a name, and you have to put the formula. But we're going to learn how to name compounds in this block.
Now, the extra credit was good because it helped us to learn the periodic table.
Mm-hmm.
So that was very good.
Good. That's good to know. I don't like to give you stuff that doesn't help you. And it also gives you extra points. Kind of buffer out later chapters if you have struggled with some. And then naming the compounds. I'm going to try to cover everything that you might find in naming compounds. Not just, we got a set of rules that we go by, but there's some extra stuff. And I want to be sure and get to that so that you can go through that extra credit and name all 50 without even cheating. I know some people do because it is extra credit. Okay. Nobody has any extras? Anything bothering you? Okay, well, I would, if you're going to review, you could just take that review document and treat it like a test. Just go through it and then go back and check yourself. Find out where you're weak. Okay, so I'm not going to give you any handouts for labs because we don't have one next week. So next week, I'll give you the lab for the following week. We don't have labs on the same day we have an exam. It's just, that's too much. We have the exam, then when you get through with the exam, we'll get the next chapter.